Hello, hello, hello. Welcome to Cloud Native London. This is our September 2021 meetup. My name is Cheryl Hung, and it is, as always, fantastic to see everybody again. Whether you're joining us on YouTube or on Twitch or on Rambly. So just to kick us off, we're going to start out with a little bit of music, which you should hear for sort of 10 minutes. Feel free to chill out, grab yourself a drink, just get yourself relaxed and in the mood. If you want to, then feel free to also go over to this link, oycheryl.com/r. This will take you to a little browser-based world. This is called Rambly, where you can meet other people and chat with them and just hang out. So again, we will start for real in about 10 minutes time. So just feel free to chill out and relax. See you in a moment. Alrighty, welcome back everybody to Cloud Native London. This is our September 2021 meetup. I hope you had a chance to go to Rambly to check it out on this link. There's about 20 people or so hanging out right now. So yeah, feel free to jump in at any time that you want to. A little bit about us. Cloud Native London is a strong, open, diverse developer community around the cloud native platform and tools in London. Usually in London, of course, like everything else, we are fully remote at the moment. At some point, I definitely hope to go back to in-person events and to see people again. But for now, it is nice to see whether you've joined on YouTube or Twitch or on Rambly. My name is Cheryl Hung, and my Twitter is Cheryl. Up till 2 weeks ago, I was at the CNCF, the Cloud Native Computing Foundation. As for now, I am gainfully unemployed for the next 3 days, and then I will start a new gig on Monday. But for the moment, I am just Cheryl. Tonight, we've got 2 talks for you. The first one is about how attackers exploit containerized Azure workloads and how to secure them, from David at Palo Alto Networks. And then we have a second talk on sustainability powered by Argo from Christoph at Helio. And then we will wrap up at 8:15 UK time tonight. So enough about me. Want to hear a little bit about you. So we usually do a bit of live polling at the start of these events. So if you have your phone or your laptop or your tablet close to hand, go to this link, oycheryl.com/p. That will redirect you to this website using a service called Poll Everywhere, where I will ask you 3 questions about you, and then 2 questions about how you use Cloud Native. You don't have to install anything. This is just for everybody to get to know each other a little bit. And if you lose this link, then there is a slightly longer one that you can see as well. But for now, just make sure you go to oycheryl.com/p. Okay. Here is the first question. Oh, I see some people already started responding. Is this your first time at Cloud Native London? So you should see 2 options, yes and no, and just select if it's your first time, then hit yes. But if you're returning, then hit no. I'll give everyone sort of 30 seconds to figure out what you need to do to sign in, and hopefully you should be able to get the answers. Looks like we've got a nice balance tonight, feeling like 70% returning, 30% newcomers. I'll just give this another second. Looks like people are still coming in. It's always wonderful to see people joining, whether they're new or whether they're back to Cloud Native London. So either way, I feel very grateful that you are here and that you're part of this with us. Looks like a few answers are still ticking in. Still looks like we're heading on a like 30-70% split. Give people a few more seconds, just because I know there's a little bit of delay as well between Zoom and YouTube, everything else. Okay, I think that is settled. Nice. So next question for you. Where are you in the world right now? So you should see a world map and just put in a little point where you are. Cool. Oh, I see some people. Well, I'm not surprised to see there's a few people heading out in the UK. Ooh, is this? Gosh, this is always testing my knowledge of geography.
Greenland.
Part of Greenland? No.
Yep.
It's Greenland, right? Yeah.
That's right.
Cool. Well, if you're joining from Greenland, that's my first person from Greenland, so that's exciting. Cool. Also, I've got a couple of people coming in from Europe, Someone coming from India, I guess. And there's a Slovenia. Nice. Yeah, I think most people are most people in the UK, but kind of got a nice spread tonight. And if you are in Greenland, like I really want to hear what you're doing there. And yeah, I would love to meet this person who's coming to join from Greenland. Oh, and someone's in the middle of the ocean. Well, maybe you're on a boat, or maybe this is a mistake. I think if it's a mistake, you can undo it and pick the right place. Cool. All right, we're going to move forwards. What is your job title? So just pick the thing that's closest to whatever you're doing. Your options are architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And if it is anything else, again, put into the chat wherever you are, what you're doing. Just would love to hear a little bit more about you. Cool. I think this is a kind of typical split for our audience. So we tend to have a lot of SRE and DevOps people. We tend to have quite a few architects. No application developers tonight, but yeah. And then a few other people. Again, just tell me what you're doing. I would love to hear a little bit more about you. Okay, answers are still changing a little bit. Looks like we are heavy on the SRE and DevOps engineers. Cool. Oh, security's picking up. Well, I would hope so, given, Palo Alto Networks. There'll be some interesting stuff to hear, I think. So the next couple of questions come from our speakers tonight. And this first one comes from David at Palo Alto Networks. And the question is, which platform do you currently use for hosting production container workloads? So options are AKS, EKS, GKE, Service Fabric, you self-host Kubernetes, RedHat OpenShift, use self-hosted Docker hosts, or I guess some other cloud platform service. David, what were you thinking?
So I'm referring to, because services, containerized service type services like Fargate and Azure Functions allows you to also host your application as containers instead of code.
Got it. Okay.
Yeah.
And what were you expecting with this?
I was expecting self-hosted Kubernetes and EKS to really top that, and it's looking that way. It's looking that way.
Yeah,
so,
well,
yeah. It's sort of in line with like what I see. Yeah, yeah. It's a very interesting one.
When you say Service Fabric, what do you mean by?
Oh, so Azure has a service, Microsoft Azure has a service called Azure Service Fabric. So, okay. Before Kubernetes supported Windows, if you're a Windows developer, you're doing just .NET development. Kubernetes didn't support Windows, so Microsoft built their own orchestrator, so to speak, to allow you to develop microservices with Windows frameworks. So that's Service Fabric. So Microsoft actually built a lot of Azure services are hosted on Service Fabric. So, and then the number is not surprising also. So.
Really? I was going to say 0, nobody's using Service Fabric. No, that's not true. Nobody's currently hosting production workloads there, yeah. Right? Oh, looks like the answers have settled a bit. So pretty even maximum between EKS and self-hosting. No one using Service Fabric, no one using OpenShift. That one I find surprising a little bit, actually. Yeah, cool. Okay, thank you. And let's go to the next question from Christoph. What is the estimated average utilization of all the servers in the world? So this is just take your best pick. Am I right, Christoph?
Exactly. It's a guess question, but I'll get to it.
Yeah, I'm very interested to see what people are guessing here.
Yeah, me too. Usually people are quite wrong about this.
Oh, interesting. People are quite wrong. So I guess utilization, when you say utilization of what?
Utilization of compute power, so essentially CPU, but also GPUs. And yeah, it looks like it actually looks like this group is quite on point. So almost half of the audience got it right.
Yay!
Congratulations.
So 19% is the correct answer here.
Exactly. Yeah, of course. Now the 19% keeps.
Yeah, everyone's gonna be like,
yeah, of course.
I totally knew that. I totally knew that. Nice. Yeah, I think 76%. That feels high to me. I probably would have actually guessed 5%, maybe. Maybe that's pessimistic.
Yeah, a bit too pessimistic, but still. 19 is still low.
19 is still good. Yeah. You can see people are definitely, now that they know it's 19%, people are voting for that. But yeah, I really I'm looking forward to hearing your talk about this, because this is something I obviously care about quite a lot. Cool. So that's it on the live polling. Thank you very much, everybody, for submitting your answers and taking part in this with us. I hope you enjoyed it, and I hope you found something useful, learned a little bit something from it too. And then I would like to say thank you to our sponsors who keep these events running, and ask them to just say hello for a few words each. So let's start with Palo Alto Networks and the other David from Palo Alto Networks. Over to you.
Pleasure. Thank you, Cheryl. Thanks very much, everybody. Yeah, just a couple of things. Yeah, I'm at Palo Alto Networks. We're not all called David there, but you're going to see a couple of Davids today from Palo Alto. We work in the Prisma Cloud team, which essentially our cloud native and public cloud division. We get to spend all day talking to customers about normally the transformation into cloud native services, understanding how they're going to secure things like containers as a service or native or managed, and also other services as well. Things like well, predominantly compute services, things like serverless and so on. So yeah, that's what we live and breathe. We focused on keeping our customers safe, normally helping them transform in some way, of course, in many ways. That cloud native really is an enabler for our customers. So that's what we get an opportunity to do, and hopefully you'll enjoy David's presentation today as well on securing Azure containerized workloads. Thanks very much, Cheryl.
Thank you so much. Zan, would you like to take the stage for Circle CI?
Of course. Hello, everyone. I'm Zan. I'm a developer advocate at Circle CI. So we're the world's leading CI/CD platform, super powerful, flexible, powering teams all over the world, helping them manage, validate, change whatever technology they're working on, whatever programming language, and yeah, whatever they're building, deploying, testing, to wherever we help that. Check us out, circleci.com, or yeah, Twitter as well.
Awesome. Sweet. Thank you so much, Zan. Lizzie, would you like to introduce Technovo?
Yeah, thank you, Cheryl. Hi, everyone. I'm Lizzie. I'm from Technovo. We're a challenger digital consultancy, and we provide expert partnership and growth without creating dependencies or disrupting culture. We work on some really exciting transformation projects across both public and private sectors, and pride ourselves on investing in talented developers, working together to provide the best possible outcomes for our clients. If you'd like to know more or just chat to me in general, you can find me in Rambly, or you can follow us on LinkedIn or Twitter for our latest updates. Thanks, Cheryl.
Cool. Thank you so much, Lizzie. NetApp and Helio couldn't come tonight, but I'm going to read out a little bit of something for them on their behalf. So NetApp unlocks the best of cloud. So you put your data to work in the applications that run your business. It's called building a data fabric, and you're in good company. And then for Helio is a time series log management solution for unrestricted event analysis scaling to multiple terabytes a day on premises or hosted. Okay, that's enough of that. Thank you so much to David, to Zan, and to Lizzie for coming and talking a bit about your companies. Again, really appreciate all of the support that you're giving us. If you wanted to come and either speak or sponsor, then go to cloudnativelund.com. Our next speaking slots are February 2022. You can also come and sponsor, or if you have an event that you want to share with the group, you can find out how to promote it with us as well. And that is it from me. So we are now at about 7:15 UK time, and I'm going to hand over to our first speaker. So David, over to you.
Hello, thanks very much, Cheryl. Thanks very much. Just to confirm, you can hear me clearly, right? My voice is coming through very well. And also, I'll start sharing my screen, and you should be able to see my screen now, right?
Yeah, looks good.
Through. Awesome. Thanks very much for that. So hello, everyone. So thanks very much for joining today. So nice hearing David, the other David from Palo Alto speak earlier. So the other David is actually my manager. So he manages me at Palo Alto. So if I say the wrong thing, just feel free to blame him, right? So, so my name is David Okeyode, so you can just call me David. So I've heard a lot of people call me David Okidoki. I'm not too fussed about that, but David is good. So I'm a Microsoft Azure MVP. So it's actually my second time being awarded Microsoft Azure MVP. So that's sort of like the equivalent of what AWS called the AWS Hero, where you get awarded for what Microsoft calls exceptional contribution to the community. So I do a lot of stuff with Azure, so you can see from the certifications, but I also, do AWS. So I've got like the AWS Security Specialty certification, the one for Azure, hopefully the one for Google Cloud eventually, and other stuff. So you can also find me on my social media handles, that I have on the screen here. So quick information regarding the agenda for today. So I realized that I have only about 30 minutes. I'd like to give some space for questions. So the information that I'll be sharing today, I'll try to condense things a bit. I'll try to make it maybe a little bit of half slide, half demonstration to make things a bit more interesting. So I'll share some information about why I like taking this approach when I do talks. So a lot of the talks that I do, if you search on YouTube, you see that I like taking sort of like this offensive pen testing approach. I actually wrote a book focusing on that perspective also. So overview of Azure Cloud, the Azure Container Services, the container threat model, container attack matrix, and some exploits demo. So again, I'll try to split my time out between just some slides, some information, some exploit demos, some key takeaways, and then we can have questions at the end. So if you have any question, feel free to put your question in the chat window or in whatever option that you have, and I'll be happy to answer questions at the end. And if I can't answer it, I've got my manager again, David, he knows everything, so he'll be able to help us. He's a really smart guy. Okay, so why do I like taking this approach when I talk about security? So there are a lot of presentations, a lot of talks, at least that I've seen on cloud security, cloud native security, that has really focused on best practices, right? The use of tools, the use of certain features, how you implement certain good practices or good security practices in your environment. There's absolutely nothing wrong with that, right? You could go on YouTube right now, search for container or cloud native security. You'll find thousands of videos that focus on this topic and that do a good job focusing on this topic. And we need that, right? But an equally important part of cybersecurity, information security, digital security is understanding attacker behavior. Like, what are the tools? What are the tactics? What are the techniques? What are the procedures that attackers use to exploit our environment? What exactly does a breach look like, right? So the reason why that is important is that when designing an architecture, understanding the perspectives of an attacker can help you design a more secure architecture. But I like the way someone said it. many people, when designing their architecture, their solutions, their implementation, they're designing for users. However, many people miss out that an attacker is also a user of your solution. So you have to keep that in mind, is that attackers are also users, and you have to look at that perspective and also make sure that you take that input into consideration. There are security gaps that I've seen working with different organizations of various sizes, where people have left their architectures exposed simply because they don't have the basic understanding of how adversaries think or how they operate and how they exploit designs, right? So I like the way someone said it, said attackers think in graphs, while they're looking at how things are connected, administrators are thinking and looking at things just in lists. So let's move on very quickly. So we also want to learn from the failure of others. It's another important thing that we want to do. So just last week, there were major vulnerabilities announced on, regarding Azure, and that gets announced like every now and then. And one of the things that we want to do is we want to learn certain lessons from it, right? So that's one of the reasons why this is important for us to look at things from this perspective. Another reason why I personally like focusing on things from this perspective is in working with different organizations, I see different patterns that emerge as I speak, with different teams and different people, in the different communities that I interact with. So one of the patterns that I see is that people seem to, or many organizations seem to have settled into what I call like the status quo of container security, right? And what I mean by that is most organizations, when they say, oh yeah, we're doing some container security, we're doing some cloud native security, essentially, I've boiled it down to three things that they're really talking about. They're talking about, yeah, we're following some, security best practices. We're doing some network profiles, we're implementing some role-based access control, and maybe a few perimeter firewall here and there. And that's what they mean when they say we have container security or we're doing security, right? So they have maybe some basic image vulnerability scan where they're scanning their computer images for vulnerabilities. They have maybe a few perimeter firewalls, and that's what they mean, right? And when I begin to look at this, speak with other people in the community, one of the things that's become very clear to me is that people seem not to be aware of the evolution of threats in this space. Many people are not aware that the same way that this space develops and evolves a lot at a rapid pace, that is the same way that attackers are evolving at a rapid pace when it comes to this, right? So I like Wayne Schwartzel's book. So it's one of the classic InfoSec books. It's called Time-Based Security. And the premise of Tim Schwartzel was that any security, right, any security implementation that you have can be evaded given sufficient time. Right, given enough time, people will figure out how to evade what you currently call security. So you have to constantly be evolving in your security approach. So that is really, really important. So threat actor tracking is very important. So understanding what are the sort of vulnerabilities that are coming out, what are the sort of breaches that are happening, what methods attackers using to evade detection or attribution. So one of the things that, again, more recently we're seeing at Palo Alto, for example, is we're seeing an increase in sort of like malware in the container space, right? A lot of endpoint protection solutions don't do anything when it comes to scanning containers for malware. And many organizations actually that I've spoken to really don't consider that to be an important enough threat vector, right? And that's a big mistake because that is one of the areas that we're seeing a lot of areas that attackers are really exploiting for many organizations. So for example, at Palo Alto, our Unit 42 threat research team. So that's the URL that you can follow below the screen there. So they uncovered the first known malware that targets Windows containers, and they tagged it Siloscape. And Siloscape is a cleverly written malware that what it does is that it's going to target Kubernetes clusters through Windows containers. So for the initial access, what it's going to do is that it's going to try to exploit common cloud applications that are public, and it's going to use known vulnerabilities to exploit them. And then when it gets onto them, it's going to, let me get a bit of my marker here. So when it gets onto them, it's going to download stuff like this cloud malware.exe file. And then that's going to use sort of like it's going to use store through an onion domain, and it's going to use that to contact a command and control center where you wait for the commands. And sort of like the methodology that it uses is that it uses it tries different Windows container escape methods to escape from the Windows container onto the node itself. And then when it successfully gets onto the node itself, it attempts to compromise credential-wide clusters, and then uses that to spread itself all through the other nodes in the cluster, and then essentially just hijack the entire cluster. And this is very severe because it's not just looking to compromise a single application, but the entire cluster and take control of the entire cluster itself, right? So another one which I won't spend a lot of time talking about is Graboid, which was also discovered by the Palo Alto Unit 42 threat research team. So, functioning in a similar way, exploiting misconfigurations in the Docker API, using that to download, to retrieve instruction from command and control servers that's been set up. And then what this one actually does is that it now uses the victim's environment as a landing spot to infect other victims. So essentially it hides behind a victim and then gets an IP list from the command and control center of other vulnerable systems. And then it begins to use that to try to compromise those. And essentially, if they're trying to track their logs, it comes back to the victim's IP address. So doing some really interesting thing there. And that's something that we're seeing that's really growing. Another aspect to this is that organizations, they've not just settled for like the status quo, they're also struggling. They're struggling to keep up with the pace of development, right? So the 100-10-1 ratio, the popular 100-10-1 ratio, which is for every 100 developers that you have in an organization, you have 10 people in operations and 1 person in security, right? And if you have a look at Google's State of DevOps report for 2019, one of the things that they found out was that organizations were doing a great job automating their builds. They are doing a great job automating their deployment. But what they are struggling with is they're really, really struggling with automating their security checks. Many people are still trying to figure out what that's supposed to look like, how they're supposed to operationalize this. And you see one of the reasons for that. One of the reasons for that is because when we talk about container security, we're not just talking about, okay, your container runtime engine and your node and the orchestrator. We're talking about something that's much more wider than that, right? So I saw a lot of people are not just doing self-hosted, they are also using, EKS and AKS on Azure. So the threat vector has just multiplied a lot. And the threat model for those platforms that you're using is completely different from, what Kubernetes uses and what the host uses and what the node uses. So anyways, I'm having a look at the time here, and now got to move very, very quickly. Okay, so Azure Container Services. So I said that a lot of people, are currently using AWS, but just some quick overview of Azure. I won't spend a lot of time on this. Azure Cloud Platform, similar to AWS Cloud Platform, one of the popular cloud providers out there. So it's not just one cloud. So Azure has 4 different clouds. So there's Azure Public Cloud, Azure US Government, Azure Germany Cloud, there's Azure China Cloud, right? There's also even Azure Self-Hosted, which is Azure Stack. So there was a very important news that came out today that Microsoft are going to switch over from Hyper-V, and essentially Hyper-V is going to be Azure Stack HCI going forward. And when I heard that news this morning, what came to my mind was I was in a meeting, I believe it was in New York, with some team members at that time. And we were having a conversation about what's going on. And one of my colleagues then said, this is what Microsoft are going to do. They're going to retire Hyper-V, and it's going to be Azure Stack going forward. And I didn't see it then. I was arguing with him. Of course, it was right. So, so just this morning, that news came in. Okay, anyways, so that's sort of like a quick overview of the Azure Cloud Platform. So all these different cloud platforms, all these different Azure clouds, they have different management APIs, they have different service APIs, different DNS zones that they use. So some update around that. So Azure Germany is a cloud that will be retired by Microsoft. So what they've done is they've built 2 new German regions, and they're moving workloads, or they're advising customers to move workloads to that. So when we talk about Azure Container Services, Azure has multiple services that we can use to build container images, that we can use to store and distribute container images, that we can use to run container images. So when we talk about building container images on Azure, we have Docker hosts, we have Azure pipelines. There's also GitHub Actions, which is gaining in popularity these days. There's Azure Container Registry tasks. So Azure Container Registry is sort of like the Docker registry built on the open source Docker registry, but with a lot of customizations and capabilities built into it by Microsoft. But Microsoft has this capability where you do not need to run your container images through a pipeline in order to update the base image, for example, right? So you can have sort of like a trigger in your registry to say when the base image gets updated, automatically updates my image without having to run it through a pipeline. So that's what Azure Container Registry task does. Of course, that's something that could be exploited with the right permissions by an attacker in the environment. So we have Azure Container Registry, which is, again, the service for storing, distributing container images and other artifacts. When it comes to container runtime options, we have virtual machines in Azure, similar to EC2 instances on AWS. We have a service called Azure Container Instance. If you're familiar with AWS Fargate, this would be the equivalent of that. So Azure actually added first before AWS had their own Fargate. So you can run containers in a serverless way. Don't worry about the underlying infrastructure. It's all managed and abstracted from you. Of course, the downsides to using a service like this is, it's very, very fast in terms of startup times. It's highly scalable. However, you have less visibility. So essentially, you have to place your trust in the cloud provider. And take the recent news that happened last week, for example, with Cosmos DB. So that's one of the questions that in the security industry, we need to be asking ourselves in terms of, with all this lack of visibility that we're having into these types of services that we're using to host our applications and our containers, what level of trust should we really be putting into that? If you were to ask me, I'll say 0. Design as if they're going to be breached. So I'll talk a little bit about that, and hopefully I'll be able to show you a demo on that. There's Azure App Service, which would be something equivalent to like the AWS Elastic Beanstalk. There's Azure Function. So Microsoft strategy is to ensure that you always have the option to be able to host your application as code or as container in all these different services. So there's Azure Batch, which is for high performance compute scenarios, but you can also run your processes or your batch processes within a container instead of on a customized image. So when we talk about services with orchestration, we have, of course, Azure Kubernetes Service. We have Azure Service Fabric that Cheryl and myself discussed earlier, Microsoft sort of like equivalent. A lot of services in Azure, like Azure SQL, are built on that. And we have Azure RedHat OpenShift. So just take some quick information around that. So what I'm going to do is I'm looking at the time here. So I'm going to quickly just talk about the container threat models. So I've got to cut out a lot of slides here, so apologies for that. So I'm going to cut out a lot of that. So when we talk about container threat models, essentially what we're talking about, it can be simple, but it's also very complicated when it comes to implementing and operationalizing it. So we have our code, right? And with our code, we all know what comes with code. We have all these application security issues, right? Like your SQL injections, your file injections, your cross-site scripting, all those type of application security issues, you have those when you're talking about your code. But your code is running within a container, right? And then you have that being run by a container runtime engine, and then that's running on a node. And that can be Windows, Linux, that could be, in many cases, it's much more container-specific OS these days, right, which are minimalist. They don't have a lot of the other things that's not necessary to run a container to help with the security. So, and then the node is being managed by either an orchestrator service or one of the platform services, like maybe Azure App Service, Azure Function, right? So some of those use orchestrators behind the scenes, some of them don't use orchestrator behind the scenes. So like, for example, a service like Azure Container Instance actually behind the scene uses either Kubernetes or Service Fabric as an orchestrator. And that's running on top of the cloud. And this is highly distributed and very complex. And you can see that there's multiple tech stacks involved. And this is part of the complication because the security models for all these different layers are completely different from each other. Like what you need to know in order to be able to look after your cloud platform is completely different from when you're dealing with application security. However, with the way that we run these today, they are all connected to one another. There's sort of like an intersection of all of this together, where mistakes in one layer impact every other layer, right? And that's one of the things that I hope that you take away from this today. So again, I won't be able to talk about this because of time, but I want to just bring this up in terms of the container attack matrix. So this is a matrix that sort of describes, the different objectives that attackers are looking to achieve in a victim's environment. So an attacker has objectives that they're looking to achieve, and then they have different methods and techniques and tactics that they use to try to achieve that. So for example, when you're talking about an attacker looking to gain initial access into an environment, there are multiple approaches that they could take to gain access to the environment. That could be talking about gaining access to a container, getting access to the orchestrator control plane, getting access to the backend data, getting access to the cloud platform itself. There are multiple aspects to that with the complication and stuff that we mentioned earlier. So compromising a cloud credential can essentially still lead to compromising the workloads, compromising images with backdoors, similar to some of like the malware that we mentioned earlier, stealing kubeconfig file. There's a very nice scenario that I wish I was able to show you today, but I don't think that I have time for that, which is talking about a way to, for example, take, so AWS also have something similar called AWS Cloud Shell. Azure has a service called Azure Cloud Shell that administrators and developers use to essentially manage their clusters or even manage their cloud platform. And there's a way that an attacker with the right credentials can backdoor that and essentially use that to harvest, if the administrator or the developer has permissions to certain clusters, use that to harvest all the kubeconfig files for all the clusters and exfiltrate that to a storage account. So I won't be able to talk through all of this today. What I'm going to do is I'm just going to leave these on the screen. So in case you want to, take a screenshot of some conversation about them later, we can always have a conversation about those. So what I'm going to do now is I'm looking at the time of about 10 minutes. So I'm going to show you like some scenarios talking about Azure. So first of all, I'm going to, let's take credential hunting, for example, right? That's one of the objectives that an attacker is looking to achieve. They're looking to steal credentials, maybe that they can use for elevating access. So in terms of credential access here. So one of the ways an attacker does that, let me bring that up and hopefully I'll be very quick here. So in this particular scenario, for whatever, using whatever method, an attacker essentially has compromised a credential and the credential has this sort of access in terms of being able to pull images from the registry. Now, one of the things to really mention about this one is that when it comes to Azure, Microsoft are really, really good with how they structure their role-based access control plane in Azure. So they have sort of like an aspect that they call data permissions, another aspect that is called data actions, and another aspect that's called actions. So whenever a permission is defined under action, in many cases in Azure, that does not give you any permission or any access to the data plane. So they are kept completely separate from each other. However, as you find out in the demo I'm about to show you, that's not always the case. There's a few cases. There's at least about 5 of them that I can count where permission on the action plane actually does give permission to the data plane, even though it's not explicitly defined, right? And those are the kind of thing, because this is essentially considered to be a management plane permission, which actually gives data plane access, right? And many people may not be aware that that's sort of like how that works. So having those sort of permission, using that to enumerate container registries and then using that to hunt for credentials in that. So what I'm going to do now is let's head over to my Azure platform, and let's go ahead and connect to this, and we'll need to be really, really quick here. So while that is coming up, so let me go to show you what I'm talking about. So if I go to access control, if I go to roles in Azure, and if I go to, for example, the reader role, which is just meant to give data plane permission only. But from, again, what I mentioned earlier, that's not always the case. If I go to examine this role, right, you can see that it lists all these permissions. But if I go to examine the JSON, you can see that under the action section, it has permission to read only. But under the data actions, which is where you actually explicitly define data plane permission, it has no permission. But that's not accurate because as you see here, it actually has data plane permission to Azure Container Registry. So you grant read access on the subscription scope, on the management group scope, is actually going to be able to download all images and all registries in your subscription with that access. So if I go over to the dashboard over here, and what I'm going to do is I'm going to quickly SSH into a Linux VM that I have set up. And let's copy that quickly. And so let's clear the screen. So first of all, if I go ahead and log in with a reader user credential. So you see here that I'm not logging in, and I've called it reader user. So I'm logged in as a user. If I want to confirm that, if I do a quick who am I, the Azure equivalent, show me the signed in user, it gives me a bunch of information here. But if I go to have a look and see what my actual role and what permission does this user have, if I go to have a look at that, you'll see that it has reader at the subscription scope. So what I'll do is using the reader permission, I'm going to enumerate all the container registries that exist on the scope that I have the access. So I can see that there are two container registries that exist in there. So what I'm going to do is I'm going to take one of them and I'm going to use that to show you the demonstration that I want to mention earlier. So to make things very quickly, I'm going to use the reader credential, which role-based access control permission, to obtain an access token that will allow me to be able to connect to the registry. Okay, so I have my access token, and then I'm going to just do a Docker login and log into the registry. You can see login succeeded there. So let's clear the screen now to make it, to give much more space. So now I'm going to begin to enumerate what I have in the container registry that I specified earlier. So I can see that there are essentially two repositories there. There's the business app repository, there's the Node app web. So if I begin to, let's go to do this. What I'm going to do is I'm going to pull down the Node web app. I'm going to pull that down locally, and that's already pulled down. And then essentially can begin to hunt for credentials within the container images that exist in the environment. So I'm just doing the Docker inspect here, and I can see that there are some environment variables that have been set here where there seem to be some certain credentials or any other information that may have been set here. And I'll tell you, like, there's been very few cases when I was doing Azure consultancy where I do that with a customer where I've not found a credential in an image. There's been very, very few cases where I've not found that. So one of the things, so for example, one of the things that you want to do in this particular cases, if I go ahead and bring up my environment here, is you need to look at things from multiple aspects. So for example, who has permission to be able to pull images in the registry? So you want to be able to analyze and monitor access, across all the different services that you're using in your cloud provider. So I'm using Prisma Cloud for the analysis here. So using the CIAM module of Prisma Cloud, which is the entitlement management module that's going to allow me to analyze access. So I'm saying, show me all the credentials that have this permission across my entire, across the subscription. So by the way, if I remove that, it's going to show me this information across my entire Azure estate. I can do the same thing for AWS also. So this is something that goes beyond just Azure. So if I go ahead and I pull out that information, what that's going to do is that it's going to show me very in clear terms that this user, for example, has permission, being a member of that group, and that permission is what has given the user the permission to be able to gain that access. And I can go ahead and I can drill down to say, show me the access that they're not using. So for example, if I say, and action dot last access days. So show me permissions if they have that permission and they've not used that permission in over 7 days. Now, if I run this, I'm not going to get any results because I just set up this environment all today. So, but you can go ahead and analyze that, right? So for example, if I want to analyze container registries in my environment that maybe allow anonymous access, I can go ahead and I can run that across my environment. And it's going to look at my entire environment and see that I do not currently have any container registry that allows anonymous access. So that's good, right? So if I want to analyze, identities that have permission on a wider scope, maybe on, people shouldn't be getting permission to be able to enumerate all your registries on the subscription level, right? If they need access to one registry, they need access to one registry. So if I go ahead and I analyze that, I can see that there's a single identity here that has permission on the subscription scope to be able to, that has that permission that I've defined on the subscription scope and on and on. So I think I've probably run out of time here. So I was trying to talk really, really fast, but I wasn't able to, unfortunately, get to the other demo that I wanted to show you today. But I can still talk, can just talk very quickly about it. So the other one I was going to show you is exploiting Azure container instances, just exploiting Azure container instance workloads. So one of the things that people struggle with Azure container instance is that it's serverless, which means you have no visibility or management to the backend. But again, the breach or the vulnerability that happened last week has shown all of us that we should really not trust very much what is going on with the cloud provider, even though they claim to be looking after those. So what we want to do is we want to ensure that regardless of where we're running our containerized applications on our cloud platform, we always have some form of runtime protection. So I was going to show you an example of that. So where you can implement runtime protection, even in a serverless workload like Azure Container Instance or AWS Fargate, right? Whether that's as code or as container, and you can have protection against suspicious activity at runtime. But again, I've run out of time here. So quick takeaways for you today. Number one takeaway is understand that threats evolve, and make sure that you're not trying to defend your environment with a wall when your adversary can fly. The wall is not going to protect you when the issues happen. Number two is be holistic in your approach. So don't just go focusing on just application security issues. You can have the best application, the most secure application in the world. If your cloud security model is bad, you're still in trouble anyway, right? You have to look at all those different threat models that I mentioned earlier. So it's 7:45 now. I don't want to take the time of the next speaker. Make sure you check out, Palo Alto product I was mentioning earlier with Prisma Cloud. I wasn't able to show some of the other demos, but I hope that you got one or two things from this presentation. So I hand back over to you, Cheryl.
Fantastic. Thank you so much, David. And yeah, sorry that we ran out of time for questions, but if people do have questions, what's the best way to get in touch with you?
Yeah.
Like Twitter or email?
Twitter will be good. So you can always check me out on LinkedIn. Just search for David Okeyode on LinkedIn. Make sure you do not type okidoki. You won't get any response. So check me out on Twitter also. So my Twitter handle is at Shagun Lodu. That's even more confusing than my last name. So
all right. Thank you so much. Really appreciate it.
Thank you very much.
Okay, let's go to Christoph now for the second talk. So Christoph, over to you.
Yeah, hi, thank you. Also going to start sharing my screen, and just a quick confirmation that you can see it. Perfect. So yeah, hi everyone. I'm sorry. All the listening made me a little bit sore throat. But anyways, hey, hi everyone. Love to be here, but I would have loved it even more if I could have joined you in London. Unfortunately, due to COVID, as you can see, I'm still locked down to my bedroom at home in Switzerland. So for me, it's already 8:45. Therefore, yeah, my day has been an hour longer than yours. Yeah, I'm founder and CTO of Helio. I've actually known Cheryl for a while, although I've never been to the CNCF meetup in London. Yeah, today I would like to talk to you a little bit about what Helio does. And then since I was asked to include some technical details, and I love to share technical details, I will show you by an example how Helio actually does what we claim to do. So our overall goal, let's say our vision, is we want to increase the sustainability of the compute industry. That's why the initial question was, what's the utilization rate of all the servers in the world? As I unfortunately already told you, the utilization rate is somewhere around 19%, which means that roughly 1 in 7 servers is only 1 in 7 servers in the world is used. However, each of these servers that exist in the world sometimes is used completely. So that means that the solution cannot be just to plug out 6 of 7 servers and then we are fine. But the reason why this number is so low is that we have a very high volatility in compute workloads. And that's why at Helio we identified that the utilization of the compute infrastructure is actually the biggest impact that we can have on the sustainability footprint of the compute industry. And that's why we decided to focus on that. The way we did that is, normally we call it the platform when we talk to investors or customers, but since this is a technical talk, I prefer calling Helio a network, because platform is like, the economists love this term, but it's a very overloaded term. Therefore, I call it the network. And Helio is a network where each data center in the world is connected to. Of course, not every single data center is yet connected to Helio, but we hope to get there someday. Because what we do is, all of these data centers that are connected to the network, they announce their capacity and, well, their available capacity. Of course, we don't want to know what's not available, what's already in use. They announce the capacity that they have to the network, and then we create a catalog of all of this available capacity. And then the model that we use is already well known. It's the spot model that we know from the public clouds. On Google, it's called preemptive, and Azure and AWS, it's called spot. But we use exactly that method to then deploy workloads into these data centers at times where they have capacity. So Helio actually brings workloads to these data centers at these times where they have capacity, which means that through Helio, they can increase the utilization of their existing assets. And that's exactly what we want. That's what we call sustainability. Of course, since utilization is our main goal, we also focus on workloads that can actually drive up the utilization, which means that Helio is not about, as Cheryl asked before, if we're talking about computational power or about, for example, about storage. Actually, we don't care much about storage, because obviously the impact that we can have in regards to storage is, since the age of solid state, is not that big anymore. So we focus on compute intensive workloads, and that are essentially, back in the days it was called batch processing, but we call it terminating workloads. So for example, CGI renderings, which is actually the example that I'm going to make afterwards, some physics simulations, machine learning trainings, or anything that you can imagine that requires a lot of compute power and is finished at some point in the future. Ideally, also we would like to have workloads that are parallelizable, but I'll come to that a little bit later. So essentially, as I said, we are a network, and one side of the network is all the data centers that are attached and announce their capacity, and on the other end of our network, there is the customers that buy compute power, and for them, it's essentially we need them to be flexible about their compute consumption. So when we want to drive up utilization, obviously, what we don't want is to serve every customer always at the very moment where they want compute, but we want to serve them at the very moment where they need compute. So that means that, as I said before, we're focusing on batch jobs. That also means that Helio is not a platform to host your website or host your web application on, because obviously when someone visits your web shop or your website, then they want a response at the very moment, and therefore this is not the domain where we are at home. But I think I hope that was enough of context, and obviously I could speak for hours about sustainability, because that's what we're passionate about, and I could also dive into the algorithm that actually is in charge of selecting the right data center and deploying the workloads there. But today I'm going to focus on the bit that Argo plays in, and therefore I would like to show you on a very, very high level, on a bird's eye view, so to speak. I'd like to show you how a specific example of a workload flows through the Helio platform onto a data center, and then the results go back. And since I'm a CTO and not an engineer, you won't see that by a live demo or a code example, but just by an architecture diagram. And I'm very sorry about the design. Although I am a CTO and create a lot of slides, I'm still very bad on the graphics design side of things. So this is the first example of my lack of skills in graphics design. But what I want to show with this slide is our approach is layered. So that means that in order for this platform to work, as I said before, we need flexibility on the demand side. That means that we need to be able to integrate into the user's workflow and value creation process in a way that the user can tell us, and I'll get to that example later. For example, I have this computational problem and I need the result by Monday because I have to ship it to my customer on Monday. So we have to be quite integrated into the use case. And in the middle, there is actually the Helio brain or our core, and that is the compute API, which takes these use case specific requirements, translates that into generic requirements or generic deployments, deploys that onto the data centers. And I call that working, but then the computation is done, and also the core has to take care of shipping the results back to the customer. Of course, also we need some supporting services, some storage, authorization, logging, billing, obviously, because we also have to eat at the end of the day. So let me go through an example, and this is an actual example from an actual customer, so that you can see some screenshots at the end. I hope I don't take too much time so that I can show you them. But the example is a CGI rendering example, and as you can see here, I took a customer use case that uses the 3D software Autodesk 3ds Max. It is an architectural studio. They take 3D or plans, I guess, blueprints from architects and translate them into computer generated but photorealistic imagery, so that they can already sell the building before it's built, essentially. And for that, this customer creates an animation with 1,000 frames. It's a 4K video, and the result should be a PNG. And this, as you can see, this is very use case specific, because Kubernetes doesn't care about frames or width and height of an image. And therefore, what happens next is when the user orders this computation, they click render, essentially. And then what happens is two things. First of all, the Helio client syncs the data into our storage solution, which can be any storage solution, for example, Google Cloud Storage or whatever. And once the input, the source files are synced, this blueprint that I mentioned before, the user can, through our API, give us all these parameters like the frame range and width and height and whatnot. And then through our REST API, tell us, I need this computation to be done by Monday morning in my example, because then I have to deliver the video to my customer. So once this is placed, then we have this. It's supposed to be a brain, but it looks more like a potato. But the Helio brain, or core, as we call it officially, then looks at few parameters and in order to eventually make a decision, we call it matchmaking. One of which is the estimation, which means, okay, we know it's 1,000 frames. We know it's half an hour per frame, which means 500 hours. And we have so many jobs in the queue. And then the most important thing actually is the resource catalog, which I mentioned before. All these data centers that are connected, they supply us with information about how much capacity they have. And therefore, with all of that information and a few more, but these are the most important ones, the Helio matchmaking algorithm makes a decision. And this decision is, in this case, okay, we need 20 nodes, so 50 frames on each node. We take an AKS cluster that is located in the Amsterdam location, the Amsterdam zone of Azure, and we are going to start tonight at midnight with this rendering. And based on this decision, now that's where the interesting part starts, or at least the topic. Everything is interesting, but at least the topic of today starts, because our core now creates a job in the queue. So it waits until midnight, as our decision was. And at midnight, we create an Argo deployment that then deploys the workload to the worker cluster, as I called it before. And as you can see here, it is like the magic is actually in this matchmaking algorithm that we select the right cluster, and it should have enough capacity. And in our example, it's AKS, because there's definitely enough capacity there for such a big job. And then Argo takes over, and Argo actually makes sure that once we deploy this workload, the workers can actually handle this this spot situation that we had before. Because since we are relying on an auto-scaled AKS cluster that only works with spot instances, the instances can die away, for example, or they can also have limitations. For example, when Azure tells us, hey, there's only 5 nodes available, then we are in trouble if we would have to do everything manually. But thanks to Argo actually takes care of queuing the workers and everything, and we then can make, as soon as our brain deployed the Argo workflow onto the cluster, onto the worker cluster, we can essentially lean back and just wait for the container to for the containers to be done. Of course, we have to observe this a little bit, because we promised the customer that the rendering will be done on Monday, 8 a.m. We know that each of these nodes is going to have to render 50 frames, and we said before that each frame takes half an hour roughly. So that means that each node has to run for 25 hours, and that is a very nice example, because as we know, spot instances shouldn't run more than 24 hours. So therefore, in this particular case, you could say, okay, the matchmaking algorithm made kind of a mistake. And but thanks to Argo, even if one of the nodes dies away, then the remaining work will be deployed onto another node, and then the work will continue. And this is actually important for us to, as I'd like to just take a step back, and this we call it kind of like the secret sauce in this is actually that we take this render workload and make it parallelizable. I don't know if this word even exists in English, but still, the point is that we can deploy it onto multiple nodes, so that when there is volatility in the data center, we need to, at these times where there is enough capacity, we need to deploy as many workloads as possible, because eventually when the supplier, the data center, needs the capacity back, obviously we have to be as finished as possible, because then we will get less nodes. Therefore, making these workloads to run in as parallel as possible is the secret sauce of Helio, essentially. Then, as I said, or I didn't say it, but I'll now come back to it. In the worker, we have essentially what that is pretty much plain Kubernetes, and we have these are also temporary clusters. Sometimes we have an AKS cluster for a few weeks, and we have clusters in other data centers that have been living for, I don't know, a few months, and sometimes the cluster just is there for an hour, or I don't know how long the job takes. But the cluster that we have there then essentially does two things. As soon as it's midnight tonight, we will create one node. Before all of the working starts, we will create one node that does a downsync from our storage into this location, this region where the work should then be done, and syncs all the input files, and also provides a persistent volume claim to where the results will then be put in. That is because, and then as soon as this downsync is done, we just run a continuous job to sync all of the intermediary results up to our storage solution, for two reasons. First of all, the user can already, after half an hour, they can start having a look at the frames, whether or not the results are satisfying. And second of all, if the whole cluster dies away, we can still downsync from our storage the intermediary results again, and then continue wherever we left off on another cluster if necessary. And furthermore, of course, one of the key things is the autoscaler that then lives in this Kubernetes cluster that takes care of. Normally, ideally, it would try to boot up 20 nodes as soon as the Argo workflow gets deployed. So as soon as the storage is ready. But of course, since we essentially can't know what the situation at these suppliers is. Of course, we're trying to guess. Our brain tries to guess, but we can't know it. Therefore, the autoscaler can also just have limits that are set by the customer. For example, if this would be another customer, they might have said that we can only use 10 nodes at this time. And then obviously we're going to have to deal with the situation if we won't make the deadline of Monday morning. All right, then I will go to the example. And first, probably I first have to just mention one other thing. For all of this to work, we originally the Argo workflow, we already used them in front, so that our brain would essentially operate on the Argo workflow. However, we noticed that with Argo, multi-cluster isn't really there yet, because the challenge that we had is that when we created a multi-cluster environment where we had 5 clusters in Argo, and then through Admiralty would try to deploy workloads into those different clusters, the autoscaler wouldn't work, because the autoscaler didn't know about the virtual capacity of the cluster. Therefore, the pods just didn't get scheduled. That's why we had to split it into 2. And you see the clock, the very nice clock, meaning that only when our core decides to actually deploy the workload, only then we would create an Argo workflow. And then this Argo workflow just lives in a single cluster, and we don't have the multi-cluster capability of Admiralty anymore, because it didn't work to auto-scale, especially since we want to scale the workers down to 0. when we always had one node running that was just idling around. It did work sometimes, but also not always. But scaling down to 0 was the challenge, because we, as I said before, we are not the typical web hoster. Therefore, our autoscaling does not work based on resource, but it works based on these decisions that our brain made. So the 20 nodes means we need 20 nodes autoscaled, and we can't wait or rely on the autoscaler based on CPU metrics, because therefore we would have to have one node always there and idling, and that's exactly what we don't want. So first of all, this is the I have to move the window where my own face is now so that I can see it. Now here you can see as you can see with the Kubernetes namespace core. This is the brain that I mentioned before, and this is a workload that the customer ordered. I don't know, I guess a day ago. This MWF means multi-cluster workflow. Sorry that I didn't write the whole thing, but this is just, I'm so used to it that I don't spell it out anymore. Anyways, so this is how a workload looks. Look, you can see one of the important things is actually the cluster decision that our brain made when the user created it. When at the very initial creation through the REST API, this cluster thing is still empty, obviously. But as soon as the decision is made, you see which cluster this is going to be deployed on. And as by the example before, you see there is the K8s AKS render cluster, which is it's a render specific cluster. I said before that the compute API is supposed to be generic and working for every type of workload, but that didn't work for one reason, and the reason is Windows containers, because the containers that are used to render this are so big. We had cold start times of 45 to 60 minutes, and obviously that's not what we want. Therefore, we made a dedicated render cluster that has images with pre-pulled Docker images. So we during provision, we use Packer to just on these nodes do a Docker pull and then bundle it into a disk and then deploy that into this cluster. So that was an optimization where we cheated, but still you can see that this is the cluster that our brain decides there we're going to deploy the workload. And therefore, in the next screen, I'm going to first show you. You see the context up here. This is again, my own face is in the way. This is the cluster, the context or the cluster that was decided upon by our brain, and then we do an Argo get on this workload, on this workflow. We see that there's a lot of information, including the resource duration. So you see that such a workload actually takes quite some compute power. And then down here you see those. It didn't fit onto the screen, but here are those 20 chunks, those 20 nodes that we deployed. And you can see here the frames. And you can see back here also the duration. You see that, okay, this is 12 frames, 32 minutes. So that means not much, 3 minutes per frame, more or less. There's also some other workflow specific stuff like a camera and everything. This concludes my demo. I had to rush through it a little bit because otherwise I would have run into the same problem as David. And I hope I didn't, it was more or less clear. And if you have any questions, if you have any questions, please write me an email. Do not write me on LinkedIn. That is just for networking, but normally I don't reply on LinkedIn because I get too many messages. Also, of course, we have a Twitter. And essentially, if you're interested in talking a little bit more about sustainability, because as I said, this is my passion, I'd say. Therefore, I'm very open to discussing also afterwards in the Rambly. And if you have workloads that would fit our platform, that based on what you heard now, that are one-off and heavy on compute, then please, I'm always very interested in hearing about them. And especially, of course, if you, for example, use 3ds Max and tried to ever render something on a Docker container, we can also, of course, share a lot of info and a lot of knowledge in how we actually pulled it off to run a Windows-based render engine on Kubernetes, and even scale down to 0. So yeah, that was my 25 minutes, and this leaves 5 minutes for questions.
Amazing. Thank you so much, Christoph. It's really nice to actually see how it all works and how it all hangs together. I'm going to take over a screen share for a moment.
Yeah.
And pull up the same service, the same polling that we were doing before. So if you have any questions for Christoph, then please feel free to go to this link. This is the slightly longer one, the poll.ev link. And then you can type in your questions, and then it's like Reddit style, so you can upvote and downvote. I think we've got probably 2 or 3 minutes until the end of the meetup, so we'll just wait and see if anybody has questions. But yeah, I mean, I really do enjoy the sustainability focus, or the motivation behind Helio.
Yeah, and I mean, it's when you start digging into sustainability of the compute industry, there is so many things that pop up, and that you start thinking about, like the trying to make only execute more useful workloads, like the degrowth of certain things. Like the most prominent example probably is Bitcoin mining or stuff like that. And then you see, okay, the supply chain sustainability of servers and all of that. And really, it's quite the ocean where you could dive into. And then, yeah, it really took us some time, because we were so excited of trying to, okay, there's a lot that we can do, or we should do, and really try to get the focus on where we can have the biggest impact was challenging, because obviously we'd love to solve everything. But, yeah.
Looks like we've got 2 questions already. First one, what are typical cost savings for customers?
Yeah, so the cost savings are, of course, a little bit dependent on the provider that we use, and therefore the cost savings are essentially directly in dependent on how much flexibility you give us. So if you have, let's say, 10 hours of compute and you give us a week of time, then we can do better optimization for your costs as compared to when you have 10 hours of compute and you want it in 2 hours. But overall, we say that we are around 30% cheaper than the spot instances of the public clouds, since we deploy into different data centers. And at worst, we are at the spot instances of public clouds. So because sometimes we do have the public clouds as suppliers on our network, and sometimes when there is no availability in any of the data centers, or we're just not sure, or maybe the machines are too slow, or maybe the customer needs TensorFlow unit processing units, obviously we're going to have to deploy it into the public clouds, and then at worst we are at the spot instance prices. But normally we say roughly 30% below.
And speaking of the cloud providers, which cloud providers do you use, and how do you choose which ones to post jobs to?
Yes, we use currently GCP and AKS, as I said. We're also doing but we have some customers that would like us to integrate also AWS, and the matchmaking is actually quite complicated. But essentially, there is a few hard factors that we have to satisfy, and also then, of course, the optimization in regards to cost and time and many more possible optimizations. But the hard factors sometimes are, as I said, Windows containers, for example. And currently we run Windows containers only on AKS. Well, we also run, we did run some of them on GCP, But yeah, it is mainly due to licensing costs. So the soft factor of cost savings is obviously better on AKS. And how do we choose? Once all of these hard factors are satisfied, so once we know, okay, this cannot run on Google, this cannot run for whatever reasons, we then do essentially just from all of the filters, all of the possible suppliers, we just do which one costs the less. And therefore, of course, we have all of the suppliers, we run some benchmarks, how well they perform. And then because an hour of compute costs a different amount of money at each supplier, but also gives us a different amount of power. And therefore, we normally opt for the faster machines. And normally that's just and I'd say this algorithm will, as long as I live, it will continue to evolve.
Yeah, it sounds, there's so many ways you could choose, right?
Yeah.
And then this third question, is Helio just targeting totally unused machines, i.e. not taking the 81% of capacity from in-use machines?
Yeah, not necessarily. So that depends a little bit on the tech, like I'd say on the hypervisor or on the decision that the supplier takes. Normally, most of our suppliers, they normally go for, okay, here is 5 machines that you can have for now, run it on those. So we're already utilizing them. But of course, if the hypervisor supports our workloads running on virtualized environments, then definitely we can also run theoretically can also run on a VMware hypervisor, where we then can be one level below, we then can be shared. What we are not doing currently, because we have to make sure that when we deploy one of our workloads, for example, this rendering before, what we don't want to do is have Argo or Kubernetes side to have multiple of these renderings on the same node at the same time, because of that's a very specific feature of the actual workload, because we know that when the CPU usage is a little bit volatile, but the render engine is capable of utilizing all the CPUs that it gets, just not all the time. And therefore, we are trying to avoid resource sharing through the Kubernetes deployment, but rather do intelligent decision in regards to how we're going to package the workloads.
Cool. Okay.
I hope.
Yeah. No, I think that makes sense. Fourth question: any guarantees provided around workload completion in the given timeline?
Yes. So that, of course, as I said before, we have these estimations that are based on benchmarks and on experience from this specific workload and also past executions. But of course, we can't be 100% sure how long a workload is actually going to take. Therefore, we are at a stage also generally with our company to still learn about the workloads. But we hope that at some point we know enough about the specific applications and the workloads. We are actually, for example, we're quite good at estimating how long a Blender rendering takes, but we are not good or enough already to know how long a Corona or a V-Ray rendering takes. Therefore, it depends on the software how reliable this guarantee is. But obviously, we are. This is still a pretty manual process, but we plan to, in the future, as soon as we know enough about the workload, actually give you some guarantees. Yes.
And then this question, I guess, about sustainability. Do you account for the carbon output of the provider as part of your algorithm?
Yes, we do. This is actually one of since sustainability is very keen to us. This is obviously one of the things that we would really love. The problem there is that it's still quite hard to actually get reliable data. So what we do is currently when we take a data center in, we just use the average network mix of the location where this data center is. But of course, there is a lot of room for improvement because, as you probably know, that the greenness of an electric grid is very changing throughout the day and also throughout the year. So it's in the algorithm, but it's the data that we use to make this decision is still pretty, I'd say, yeah, pretty early. I wouldn't say bad, but there is a lot of room for improvement in this data, but definitely very important aspect.
It's actually really nice to hear. I was kind of expecting you to say no, so it's nice to hear that's something that you already take into account.
Yeah, of course, absolutely. I mean, everything still has to work, but this is definitely one of the soft factors that I mentioned before that are then going into the optimization.
Fantastic. We are a few minutes over time now, 5 minutes, but I wanted to get through all the questions. So thank you everybody for submitting those, and thank you, Christoph, as well, for speaking and for chatting to me about all of everything that Helio is doing right now.
Thank you very much for having me, and I'll hang out in the Rambly, it's called, right?
Yeah, Rambly, yeah. So yeah, that concludes our meetup, Cloud Native London, September 2021 meetup. Again, I'd like to thank everybody who joined, who submitted questions and took part in our polling. We'll be back again on the first Wednesday of the next month, so first Wednesday of October, and I will see you again then. Take care.